All right, let's do our multiple choice. Here we go. So we're first talking about several questions relating to power. And so what we want to remember, and I have a picture of it here, is that power happens if that null is false. And we have all of our data over here on the right, where we have all these samples to lead us to reject that null hypothesis. So it's all the samples that lead us to see that there is an effect, because there really is one. So that's what we want to reference when we look here, detecting an effect if one really exists. All of those samples over there. Now then we just kind of do some of these in context. So of course HA is there is an effect. The new smart speaker works better than the old. So power would then be being able to detect that the new smart speaker works better if it really does work better. Here is this next one, also about the power of the test about a particular medicine. Is this medicine significantly better? Am I able to detect that difference? So am I able to detect that type B medicine works better when it actually does work better? And now here is one where we're referencing what can affect the size of the power. How can I make power be the largest? So here's our picture to remind ourselves of that. So here with this, I'm going to look at this picture over here on the left. And so I can see increasing power would happen if alpha is going up, the sample size is going up. So the largest alpha, the largest sample size, and let's kind of look at this. Remember this little green circle down here at the bottom? That is talking about the effect size. How far HA, the actual data, is, that effect, that alternative, away from the HO. So I think I have a picture of that effect size here. So here is that effect size where you can see that the farther that you are away from the null hypothesis, see here it's closer, but here HA is farther. The farther you are away, then the more likely you are to have more samples that will allow you to detect the effect and reject the null hypothesis. Okay, so that's what's happening there. So we go through and we find those highest alpha, highest sample size, and then here we're left down to D or E. And then this is when the effect size comes into play, because we were told in the prompt that the null hypothesis is 0.15. So we would want to find the one farthest away, the actual values farthest away, which is 30 as opposed to 25. All right, next we have got, again, just looking at our type 1 error. So our type 1 error is that ability, probability that researchers think they have discovered something, but there is nothing there. So but there is none. So they get these samples up here thinking they have detected an effect when there really is not one, because the data is centered around the null hypothesis. The null is true, but we reject it. If the null is really true, so if the immunotherapy treatment, we think they conclude that the immunotherapy treatment is effective when it actually is not. You can see this one, answer choice B is the type 2 error. On C, keep in mind it's not an error. Because you are making the decision that is correct decision. In fact, you are detecting the effect when there actually is an effect. That's power. All right, and then D is not an error either. So here we are detecting if we have evidence of that this program is creating a higher rate that meet the minimum standards on the TSI. So type 2 error is what we're wondering about. So I think to myself, type 2 error, HA is true. So the real results are that the program is giving me evidence that it is increasing the success rate on TSI, but we did not detect it. So type 2 error, there is an effect, but we did not detect it. So here we go with, so therefore that's this. Does not provide convincing evidence. We think P is still 0.5, but the actual meeting standard is greater than. P is greater than 0.05 or 0.5. Okay, so you just have to kind of baby step your way through those. Here we have one where we are asked what change can be made to decrease the probability of a type 2 error. So what that does is then it makes me think about my picture that would make this type 2 error have the down arrow. So if it has the down arrow, then I can see standard deviation is going down. This is the H, this would be the opposite. HA is getting closer to HO. So, oh, that's not true. It's what's on here. So HA is farther away, making that type 2 go down. I'm going to show you that picture. Here that is, because I said that wrong. Here it is. Do you see here that we have this type 2 error here, but if your data is farther away, HA is far away, see, look, then our type 2 reduced. Okay. All right, so just clarifying that. One thing I wanted to point out, you know what standard error is? Standard error is this standard deviation, but made with the p-hats instead of true p's. All right. So the sample size increasing is the only one represented on this picture. Here we go. Alpha plus beta is 100% of the data. And you can see that right here. See, here are, power plus beta is 100% of the data. So the yellow plus the orange, 100% of the data. So that's how I then just did the math of finding solving for beta. Okay. This one kind of messed with my brain when I did it. So I'm considering the results of this test. And so the test is indicating that we do not have enough evidence to reject the null hypothesis. So we are failing to reject the null. And then it says, which of the following statements about error is correct? So I have to think to myself, what error is happening where HO is not rejected, but it should be? So failing to reject the false null hypothesis. And that would be this type 2 error. Let me see if I can find a picture. So type 2 error here is us. See, here we are failing to reject this false null hypothesis because the data is all over here, not rejecting the false null hypothesis. Alrighty then, next. Oh, I said I was just going to go through 10 and I kept on going, so sorry. So that was number 5 through number 13. Okay, so I was just going to do these in smaller videos. So there's your number 5 through 13.